Hi Llamas, a short video on finding the eigenvalues and eigenvectors associated with a 2 by 2 matrix using Geogebra. I've pre-entered the matrix we're going to use, A, 3, 4, negative 2, 3, 4, 2, 3, and I've gone ahead and pre-entered the 2 by 2 identity matrix again using the uh, create matrix from spreadsheet form. So I'm going to do this in the CAS window. So I'm going to start by creating the matrix A minus T times I. I'm then going to compute its determinant. I'm going to solve that equation. 2 equals 0. Gives me two different values for t. Negative 2 times the square root of 2 plus 3, 2 times the square root of 2 plus 3. Those are the eigenvalues. I want to work with the first of those eigenvalues in the list and then compute its associated eigenvector. And so to get that element from the list, there's an element command. Element, it's list 3, it's position 1. So that is the eigenvalue that I'm going to be computing things with. So I'm actually going to solve the associated system of equations A times some vector equals t times that vector, where t is the value in row 4 of my CAS. So I'm going to go ahead and start making that. So I'm going to make a vector with general coordinates x, y, and I'm going to create A times that vector, and I'm going to create t times that vector, and now I want to substitute the value of t that I've chosen from that list. So to do that, simply go back to number 7, which is where I have t times the vector, and then use the substitute command, and it's going to ask you which variables you'd like to substitute for. I'm going to substitute for the value of t. I'm going to use what's in number 4. So the new expression for t is the thing that's in number 4, and say equals, and now I have that substituted in for t. So now I want to solve the equations for A times the vector equals t times the vector. So let's see if we can do that. That's solve. So I need solutions, list of equations. Number 6 equals number 7. And the variables I want to solve for are x and y. There we go. So we have a solution. X is negative 2 times the square root of y, and y is just y. So if I pick a value for y, I can get a vector that is an eigenvector associated with that eigenvalue. So let's see. A convenient value to pick is 1. Notice we can't pick 0 because we need a non-zero vector for an eigenvalue. And so I'm just going to substitute in, pick that, and then substitute for y the value of 1, and there I have the vector. X is negative square root of 2, y is 1. So there's one of the eigenvectors associated with that eigenvalue.